All right, pre-AP 11. Let's take a look at factoring in radicals lesson 2. Oh, we lost it. There, teacher. There we go. Okay, so what we're going to look at, we're going to look at polynomials that have this specific form. Ax squared plus bx plus c. And they mostly come from when we have factors that do something like this, 2x plus 1 times 3x minus 2. And if we were to FOIL it out, right, then we get 6x squared minus 4x plus 3x minus 2 collected. This becomes 6x squared minus x minus 2. And we'd have to think about how we factor that. So the idea is we want to actually go this way back to the factors. All right, so some things that we can do and take a look at is let's try example 1 here and think about what we're doing there. We want to factor. Let's factor 2x squared plus 7x minus 4. Okay. Here, we're just going to use the box method. And the box method is great because we're just going to kind of like guess and check with what we're doing here, right? We want to find a middle that adds to 7x, and we want to find an end that that multiplies to negative 4. Now, the middle is quite a lot higher than the end, so I'm going to say, well, 2 times 4 is 8. So I'm going to make that plus 4. And I just need to take away 1 to go from 8 to 9. So here's what's happening is that this multiplication becomes 2x squared, and this becomes negative 4. When I go on one diagonal and the other diagonal, well, that becomes 2x. That becomes 8x plus negative x equals positive 7x. So that gets me what I need, right? So my box method got me 2x minus 1, x plus 4. So I can use the box method to factor these very nicely, and it works out well. So let's try a few more with the box method, see how we're doing here. One thing that we got to keep in mind as well too, if we're going to factor these, so let's factor this one, negative 8x cubed plus 10x squared plus 12x. And very first thing we always have to do is take out a GCF, right? Do the GCF step. Looks like common factor of negative 2. I want that x squared to be positive and a negative x. Or sorry, just an x. I'm going to take out negative 2x, negative 2x, negative 2x. And then up front, I'm going to get negative 2x. And then 4, negative 8 divided by negative 2 is 4. X squared divided by x is x cubed divided by x is x squared. This is going to be minus 5x, and this is going to be minus 6. Okay, good. Whenever we do the box method, I like to split the factor, like whatever's up front, into the pair of composite factors first before I do 4 and 1. So I'm going to try 2 and 2 before I try 4 and 1, right? So I'm always going to try that first, and let's see what happens. And let's try, okay, this is going to be... let's try make this 2 and 3. And anyway, I do that, positive 4 minus 6, that's negative 2. And if I did this as positive 3, negative 2, let's see what happens. Since each is 2x, this is minus 4, that's plus 2. So that's not going to work. And I don't think I'm going to get any better with the 6's here. So seeing that, let's put it together. Let's keep a negative 3 and a negative 2, but let's make one of these a 4. And I'm going to do that to the one that doesn't have the negative 2 on the end, right? Or a 2 on the end. So let's try this out. Let's make that negative and let's make that positive. So let's see. This will be along the column here. I'll get 4x squared. I'll get negative 6. This will be positive 3. That'd be negative 8. So negative 8 plus positive 3 is negative 5. Everything works out. So I'm going to get x minus 2, and I'm going to get 4x plus 3. And I want to be, and I'm going to have the negative 2x in front of it. So I'm going to have negative 2x, and I'll have x minus 2, and I'll have 4x plus 3. And I want to be clear here that I chose it strategically that the 4x was down here on an opposite corner from the -2 because we never want to have GCFs on a same line, because if we have GCFs on the same line, that means we didn't take a GCF out originally. And we did take a GCF out here. So if we've taken a GCF out, we will never have a GCF on the same line in the box method, okay? So that's one way to tell if your box method is working or not. Okay, and make sure, and like I almost forgot here, to have your common factor as part of your final answer. If you don't have your common factor as part of your final answer, that's incorrect. Okay, let's show you a method that is, if you can keep track of things well, this method results in perfect factoring every time. And I didn't teach this in class, but you can use it, and if you use it, there will be no points taken off against you. And I find, like, personally, I use this method when I get to really doozy type questions. Okay, so this one, what I'm going to do is, step one here is I'm going to take this, I'm going to rewrite this. I'm going to do 2x squared, and we already know the answer, this same question from number 1, but I'm going to take this 2 and I'm going to multiply it to the -4, okay? So I'm going to do -4 times 2 here, and that 2 will go away. So my second step here, and I'll do less steps on the next one after this, be x squared plus 7x minus 8. Well, now I can factor that. I'm going to factor that one, and I'm going to get x plus 8, x minus 1, right? I can see that from the box method quickly, x plus negative, and it works out. But now what I have to do is divide each by 2, right? So what I'm going to have is, my next thing here is I'm going to have x plus 4. I recognize that factor. Then I also have x minus 1/2. But I'm going to take that 1/2, and that actually, the denominator for this actually lives in front of the x in the term that's 4. So this will be x plus 4, and the denominator will be 2x minus 1, like that, right? So that'd just be like that, and that's the same thing if we did the check, right? We'd get the same thing back. We'd get 2x squared plus 7x minus 1. So totally okay to factor with this method. So let's try it with example 4, where we'd have to do a ton of guessing and checking with this front factor of, if we factored 12x squared, so we're going to factor 12x squared minus 5x minus 2. And with the box method, that's going to take a lot of time, but let's turn this into x squared minus 5x minus 24. And in the box method, x and x, that's going to be minus 8 plus 3. So I'm going to get x plus 3, x minus 8. Yep. And then I'm going to divide each by 12. And so that means I'm going to have some fraction. 3 over 12 is 1 over 4. And this will become 2 over 3, x minus 2 over 3. And those denominators just go up front, and I'll get 4x plus 1, and I'll get 3x minus 2. Okay, let's FOIL it. Be sure that we're going to get what we get. So foiling it, I get 4x times 3x is 12x squared. 4x times -2 is minus 8x plus 3x minus 2. This gets 12x squared minus 5x minus 2. So I got the original back. Well done. Good job. So that method works out if you don't like doing a whole bunch of guessing and checking. You get to turn it into a way that you know how to do quite easily, and it works well. Okay. Another thing we're going to look at is perfect square trinomials. And what I mean by perfect square trinomial is if I have ax squared plus bx plus c is going to be some trinomial that is, I don't know, let's give it different letters. Px plus q all squared, right? Because there's going to be different factors and stuff, but it just means is that the linear factor repeats, right? That I have a factor times itself. Linear factor repeats, or factor times itself. So I'm looking for a perfect square. And we're going to use this idea of perfect square quite a lot in when we do quadratics, because it's going to be tied to the idea of a vertex of a quadratic function, right? So we're going to do perfect, like the idea of perfect square comes in a lot there. So a couple things we need to note. Okay, last term, C, is positive and a perfect square. Okay, positive and a perfect square, something that's necessary for it. So our perfect squares again are list 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 192, 225, 256, 289, and so on and so on, right? So just 324 is the next one, 19, 361, I think, and then 20 is 400, 441, and 22, 484, and I think that's as far as my memory goes. Okay, and then B, the first term, ax squared, is also a perfect square. So that a, that constant, has to be also a perfect square. So a is equal to 1, 4, 9, 16, 25, blah, 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 something like that, right? So our first term has to be a perfect square. Also, C has to be like 1, 4, 9, 16, 25. So it needs to meet that criteria. And the coefficient of the middle term is the square root of the first multiplied by the square root of the last. So this just means middle, or B, middle, the B term needs to be the square root of A times the square root of C times 2 is equal to B. So if we'll see what that means in a moment. But we're going to see that the pattern is basically going to be a squared plus 2ab plus b squared ends up being a plus b squared, right? That this is a is the square root of a squared, b is the square root of b squared, and then 2 multiplied by 2, so that's the b term there, right? And then I can also do this with a positive at the end, so I can have a negative in the middle, and that's going to be plus b squared here. And then instead of having a positive between the two terms, I have a negative. So that's my perfect square. So what does it look like for some of my examples here? So let's go through them quickly. So for number 5, if I have x squared plus 8x plus 16, well, then I know that 16 is square, that's 4, that's 1. 1 times 4 is 4, times 2 is 8. So this is a perfect square. So I'm going to get x plus 4 squared. I don't even need to do the box method. If I have 4x squared minus 12x plus 9, the first term, 4x squared, is a square, 2x is the root, 9 is a square, and it's positive, that's 3. So let's multiply 2 and 3 is 6. 6 times 2 is 12, and I have a negative 12, so I know I'm going to have a negative in the middle. So this is just going to turn out to be 2x minus 3 squared, like that, right? All I'm looking at is just fitting this into the pattern. I can also do this with composite functions, x minus 2y squared minus 2x minus 2y, and then plus 1. Well, 1 is a square, x minus 2y is a square, and then 1 times x minus 2y times 2 is still the same thing there, so that works out. So that's 1 and 1, so I'm going to get x minus 2y, and this is minus 1 over here, all squared, and I can break it out of the brackets. I'll get x minus 2y minus 1 all squared. So that works out over here as well too. Good. Let's see. Let's do the last thing. And this is just, hey, what's going to make this a perfect square? Okay. So x squared plus 6x plus k. I want to make this a perfect square. Well, what I need to do is that I need to do, this is 1, so I need to find 1 times something equals 2. Hold on. 1 times something is equal to 2 times 1 of something is equal to 6, right? I don't know what that value is, right? But I need to get this 1 from the front. That's from the first term. The 1 is coming from here, right? That 1 is coming from the front. And I need to figure out what that is. It's actually like you can do this by sight, but I want to make sure that we mechanically know what's going on. If we solve this, we know that the only thing that this could be is 3. So, but that's the square root of k, so then k has to be 9 in order to make it to work, to be a perfect square. So here I'm going to get x squared plus 6x plus 9, and that becomes x plus 3 squared, x plus 3 squared. So k is equal to 9. Perfect. So I'm going to do this a little bit faster for the next ones. Next one we have is 9x squared. I find this type to be easier, minus kx plus 4. And if we have a k in the middle here, well, I'm going to take 3 and 2, that's 6. And then 6 times 2 is negative 12. So the only thing that's going to work here for this is going to be k is equal to negative 12. Let's put that in, see what happens. 9x squared minus 12. Well, it can't be minus 12 because I have the negative already there. Minus 12x plus 4. And that will factor down into 3x minus 2 squared. So that works out for us. And the last one is just like the first one. I'm going to have kx squared plus 12x plus 9. And then so I know that I have to get 3 times something times 2 is 12. Well, 3, so that's going to be just 2, right? So that's just going to work out. So, but that means the k, that's the square root. 2 is the square root of k, so then k squared is 4. So this is going to be 4x squared. K is equal to 4 plus 12x plus 9, and I'm going to get 2x plus 3 squared. Perfect. So that's it for these kind of trinomials, right? So make sure that we consider that. I hope you're following along in your book as you're doing this. But I'm glad that these are working out for you, that they're there as a resource. All right, have a good day. Thanks, Precalc 11.